In session 71 here, we're going to be factoring polynomials that include degrees higher than 2. Now we're not going to get that in depth with this here. You'll get into more of that in some advanced algebra as far as coming up with some additional methods of factoring polynomials that have degrees higher than 2. But if you run into those in this course here, in the course you're taking, the strategy you need to use to address it is that you first of all take a look at each of the terms. And what you're looking for is a common factor in those terms that you can factor out. Well, first of all, remember we want to factor out coefficients. Well, here our coefficient for x to the fourth is 1. For our second term it's 6, and for our third one it's 7. Well, so there's nothing we can factor out there. Next, we take a look at our x variable. We have an x to the fourth here, an x to the third here, and an x to the second here. X to the second can be factored out because x to the second can be multiplied by something else to each of these terms here to give it what we're after. So let's factor out the x squared. So we're going to bring out the x squared, and now we're going to have 3 terms inside the parentheses here. 1 for each of these 3. X squared times what equals x to the fourth? Well, x squared times x squared is x to the fourth. Okay, let's take a look at our second one. X squared times what equals 6x to the third? Well, that would be times 6x. X squared times 6x is 6x to the third. Lastly, we have a negative 7x squared. X squared times minus 7 equals minus 7x squared. So what we got here is x squared times x squared plus 6x minus 7. Now let's take a look at what we have left here. X squared plus 6x minus 7. Let's see if that factors any further. And we're going to find out that it in fact does. So I'm going to leave the x squared out front here, and we're going to try to break this down. We're going to try to break down this trinomial into factors of 2 binomials. We take a look at our x squared term. There's no coefficient before it, so that's just simply going to be x and x. We now take a look at our constant term, minus 7. There are only 2 factors for 7, 1 and 7. But we need a minus 7 here. So that either means we're going to need a minus 7 times a plus 1, or we're going to have a 7 times a minus 1. Those are going to be our only 2 choices there. But before we just slap that 7 and minus 1 in, or minus 7 and plus 1 in, let's take a look at our middle term here. That'll give us a clue as to where we position these numbers. We're after a positive 6x. So if I were to place a minus 7 in here, that would give us a minus 7x plus a 1x. That would give us a minus 6x. And what we want is a positive 6x. So what we really need here is a positive 7. So we'll go ahead and make this a plus 7. And we'll stick a minus 1 in there. Now let's go ahead and multiply this out. We're going to just rewrite our x squared here. That's out front. That hasn't changed. Now, what is x times x? Well, that's x squared. What's x times 7? Well, that's a plus 7x. Our second term, distribute it. Minus 1 times x is a minus x, minus 1x. And then minus 1 times 7 is minus 7. 7x minus x is 6x. And as you can see now, x squared plus 6x minus 7 is in fact what we had up here to start with. So the question is, what is x to the fourth plus 6x to the third minus 7x squared factored? After we factored out the x squared, we then factored x squared plus 6x minus 7 into x minus 1 times x plus 7, and that all being multiplied by our x squared that was originally brought out at the beginning. So there's our factorization of this higher degree polynomial. Let's take a look at one more here, and then that'll wrap up this particular session. We have x to the third plus 10x squared plus 25x. Once again, we take a look. Are there any coefficients that we can factor out? No, we have a 1 here, a 10, and a 25. If it were just a 10 and a 25, we could factor out a 5. But we also have a 1 here, and there's nothing else we can factor out with that 1. So there are no coefficients that we can factor out. Are there any x terms that we can factor out? Well, yeah, each one of these three terms has an x in it. This has an x to the third, this has an x squared, this only has an x to the first. So the biggest that we can bring out is that x to the first. After we've brought it out, we now need to find out what's left with each of these three terms that when multiplied by x gives us those. So then, x times what equals x to the third? Well, x times x squared equals x to the third. X times what equals 10x squared? X times 10x. Positive 10x equals 10x squared. Then lastly, x times what equals 25x? Well, x times 25 equals 25x. Are we done? Well, we have a trinomial left here, x squared plus 10x plus 25. We need to take a look and see if we can, in fact, factor that. And the answer is that yes, we can. So I'm going to rewrite that x there, and I'm going to take this trinomial, and I'm going to break it into two binomials. So there's our first one in parentheses, there's our second one. We start with our x squared term. That's going to be an x here and an x here, because that x times that x is going to give us that x squared. Then we take a look at our last number here. It's 25. Well, what are the only factors for 25? We have 1 and 25, and we also have 5 and 5. What we're going to see here is this x squared plus 10x plus 25 is actually the sum of two squares. So once again, we have 1 and 25 as our choice, and then also 5 and 5. If I put a 25 in there and multiply by that x, that's going to give us a 25x. That's way too big for the 10x that we're after. So let's try our 5 and our 5. Now then, let's go ahead and multiply it out. I'm going to rewrite this here, x. Now let's take this x times that. That's going to give us an x squared. That x times that 5 is going to be a plus 5x. That takes care of our first term. Let's distribute our second term. 5 times x is another 5x. And then 5 times 5 is 25. And if you take a look at our two x terms here, this 5x plus the 5x makes a 10x. And what we now have on the inside is x squared plus 10x plus 25, which is what we had up here. So what is the, if we were told, what is the factorization of x to the third plus 10x squared plus 25x? It is x times x plus 5 times x plus 5. And we could, in fact, rewrite that as x times x plus 5 squared. That x plus 5 in parentheses squared is the same thing as x plus 5 times x plus 5. As a quick review, when factoring higher degree polynomials, first look for common factors in each of the terms, whether they're the coefficients or whether they're the variables, and then factor them out. Then look at what remains and apply your other factoring strategies to see if what remains can be factored any further. And remember, some of your other factoring strategies would be squares, the difference of two squares, the sum of two squares, etc. Okay, that finishes up session 71.